All right. Hey, class. So today we are going to take a quick set of Cornell notes. You're going to view this through Educanon, so expect it to stop and ask you some questions along the way. Again, the questions won't be hard. They will literally come straight from the notes I just gave you. So if we stop and ask a question, just look back over the notes that you just took, and you should find the answer in there. Okay, so let's get going. So this is centripetal force notes. So if you need to label the name of your notes up at the top, go ahead and call it centripetal force notes. You can see that. Let's go ahead and write an essential question. Okay, so EQ is going to be what is centripetal force? Centripetal force. Ah, dang it, I didn't mean to do that. Okay, force. And what affects it? So we've seen in our different lab experiments we've done that we know there's some stuff that affects it. We know the radius of the circle affects it. We know the mass affects it. We're also going to see that velocity affects it, but we're going to see an equation for centripetal force that's going to help us see exactly how those things affect the force itself. So first, let's go ahead and answer this question. What is centripetal force? And we've answered this before, but I think it's worth writing it one more time on a set of notes, okay? So centripetal force. Centripetal force. And here I'm going to go ahead and I'm going to put some, in parentheses here, our notation. So centripetal force, we can shorten it by calling it FC. So remember how we had FG, we had FN. Well, now this is a new one, FC for centripetal force. Okay, so centripetal force is any force, that's an A, any force that keeps an object traveling in a circular motion. Okay. And then a second sentence that I want to add on to there that we need to remember this, okay? Centripetal force always points toward the middle of the circle. Okay. Good. So now there's going to be a question about that. Centripetal force, any force that keeps an object traveling in a circular motion, and it always points towards the middle of the circle. And the other thing that we want to remember about centripetal force is, and we'll make this sort of a little subnote, it can be any force. So like, for example, it could be tension. Now, we've seen tension a bunch of times with our car tied to a string. Tension was a centripetal force. It could be gravity, okay? So when planets are orbiting, gravity is a centripetal force. It could be friction. Okay, so we talked about this a bunch when we're driving a car. Friction is a centripetal force when you turn your car. It could even be something like normal force. So I know you guys like those rides at Worlds of Fun that stick you to the wall. Well, in that case, centripetal force is the normal force of the wall pushing you towards the middle of the circle. So it could be any of these things. So that's our definition of centripetal force. Now what I want to do is let's move on, and I want to talk about an equation for centripetal force. Okay, so this section is going to be called centripetal force equation. Okay, centripetal force equation. Now the equation is actually, it's fairly simple. There's really only three parts of it. But I'm going to go ahead, I'm going to zoom in here. And here's our equation. FC, so remember FC is centripetal force, is going to be equal to mass times velocity squared divided by radius. Okay? So let's go ahead and whatever works best for you guys, how about we box it in? Okay? If you have a highlighter, this is a good time to highlight. Okay? So I'll go ahead and highlight just so, let's highlight in yellow. I like yellow better. Okay, I'll highlight in yellow. So this is an important equation. Now let's talk about what this means for centripetal force. Okay? So first off, let's remember that M equals mass, and it's measured, here, let's do this actually. Sorry, before we get to that, remember that FC is centripetal force. Centripetal force, and it's always measured in newtons. All right, now, mass, M is mass, which is going to be measured in kilograms. Now, what I want to do is I want to write a note here for what happens to the centripetal force when we change mass, okay? So let's, I've got kind of a neat thing I want to show you guys here, a little demonstration, okay? All right, so this is this website is called Desmos. It is an online graphing calculator. Now, we're actually not going to use the graphing section of it. We're just going to create the equation. So remember, our equation, if you look at your notes, is F equals mv squared over r. Okay, so that looks just like the equation you guys just wrote. Now, Desmos does a neat thing. It lets me add sliders. So I'm going to add all 3 sliders. And here's what it does, okay? So this says if m equals 1, v equals 1, and r equals 1, then the force, the centripetal force, is 1. Okay, and I wonder if I can do like, I don't know how to do subscript. We'll deal with that later. And so what I could do is, we want to know, how does changing the mass change the force? So if the mass is 1, the force is 1. But what happens if I increase the force to, say, 2? Well, look what happened. The force increased to 2. And remember, this makes sense that when we add mass, so when we make the mass heavier, so when it's 3, it goes to 3. When it's 4, it goes to 4. So when I add mass, it increases the force. And that makes sense. Remember, when we're talking about a car, a heavier car takes more force to turn. Okay? So let's go ahead and let's write that down real quick. Okay? So more mass equals more force. Nice. Okay. Now remember that V is velocity, which we're always going to measure that in meters per second. Okay. Now we want to figure out, how does velocity affect force? And you can already think about this. If you're in a car and you're going fast, it's harder to turn than if you're going slow. But let's take velocity, and so it's 1 now, and then the force is 1. But let's increase it to 2. Okay, so I increased the velocity to 2. Look what happened to the force. It increased to 4. If I increase it to 3, now all of a sudden it increases to 9. If I increase it to 4, it goes all the way up to 16. So remember that when I was changing mass, it was just going up by 1 every time. But now when I'm changing velocity, it's going up by a bigger and bigger amount every time I increase. So when I get this all the way up to something like 8, now my force is huge. So even though I didn't change velocity a lot, it's changing the force a ton. And here's why that happens. Okay, so some of you guys that are in, say, Algebra 2, you might recognize this. But what's happening here is that this, and here I'm just going to highlight to show emphasis so you guys don't have to highlight again. You guys see this squared right there? Well, because of that squared, that means that velocity has a bigger impact than mass does. So what we're going to write is more velocity. Ooh, that got bad. More velocity equals more force. But I want to put a second note in here, okay, that says bigger impact than mass. That's really important, okay? So increasing the velocity has a bigger effect than increasing the mass. Okay, let's do the last one now. R is for radius, and that's always going to be measured in meters. So let's see what happens now when I change the radius. Oops, okay, so let's set this back to 1 so it's easy to deal with. All right, so now I'm going to change R and see what happens to the force. So when I change R from 1 to 2, not 2.1, 2. Look what happened. The force actually got smaller. It went from 1 to 0.5. What if I change it to 3? Now it goes down even smaller to 0.3. Let's change it to 4. It goes down even smaller to 0.25. So as I increase the radius, now the force is actually getting smaller, which we saw that happen, okay? We talked about this. Bigger turns or bigger circles take less force. That's why taking a big left turn in your car is easier than taking a small right turn. Okay, so let's write that in our notes. Okay, so more radius equals less force. Okay, guys, that's all we have for our notes, and you've answered some questions as we've gone along. And next up, you're going to have some practice for this.